the third largest country among the world. So there is to reduce this emission. The plan is there is a Paris Agreement among different countries. The plan agreement is we have to reduce this 30 to 33 to 35% emission intensity by 2020. The 33 to 35% of the level which was being generated at 2005. So the amount of emission that is being generated at 2005, it is agreement. It is agreed that we have to take the proper precautions so that the emission can be reduced to 33 to 35% as compared to 2005, and this has been agreed. This agreement has been signed in Paris. Okay, so that and it will be reduced by 2030. The plan is how that can be reduced. The 40% of the installed capacity to be renewable nuclear by 2030. So what does it mean? So let us look after this emission scenario. Actually, if we look after these emission scenarios, there are non-carbon dioxide emissions, there are carbon dioxide emissions. So all these are, so the blue and violet lights are primarily of carbon dioxides due to transport. Okay, so this is basically, for this reason, we are converting our vehicles to electrical vehicles. These are the plan of the system. So these are the contributors which are actually generating carbon dioxides. And these are the scenarios. So we can see this. So these carbon dioxides are being generated more and more as the days are coming. With the installations of the new thermal power plants, okay. So the plan is now we need not go for additional or new thermal power plants. We have to install renewable energy sources. Instead of installing new thermal power plants, we can install nuclear or renewable energy sources, and that must be 40% of the total capacity by 2030. So that's why we will not increase our at the present state. We will not increase our total emission of carbon dioxide, what is till now today. So by 2000, since the capacity of the system, power systems will go up, so the 33 to 35% reduction emission will be possible. Okay, now the questions of whether we will install for renewable or the nuclear. So there is a kind of controversy of installing nuclear power, but there is no controversy of installing renewable powers. So the renewables. So there is now getting an evolution in the electricity generation as per our demand of the society. Okay, so for our survival point of view. So the conventional power generation system is like this. So I have already explained. Now the future is proposed with this non-conventional resources. Though solar and wind still now considered as non-conventional, but they are now being installed at plenty. Okay, so these will also now become conventional. Solar and wind will now become conventional resources, but they are renewable. Okay, to be termed as conventional generations. Earlier it was non-conventional, but it will now become as a conventional resources. Okay, biomass, biofuels. So there are various ways of generation of fuel cells, biomass, etc. Those are also renewables. Waste energy, we can generate energy from our players of our next generation power resources. Okay, so that we will not generate much amount of carbon dioxide emissions or greenhouse emissions. Rather, we can keep it at a particular level and we will not increase it. Okay, So, but if we look after the characteristics of these conventional resources, they are highly intermittent. In contrast to these conventional resources, they are stable in the sense the wind or solar, they are the major contributors. If we look after the wind or solar, they are highly intermittent in nature. What does it mean? As if they are not available at date. Solar may not be available at evening time, or wind, we do not know when wind will flow. They are highly intermittent in nature. At the same time, we cannot guarantee the solar will be available throughout the sun will be available throughout the daytime. Okay, so their availability is highly intermittent. In contrast to this, the just a minute. Car এই একটু জানলা আসবেন। হ্যালো, এইদিকে এইদিকে একটু আসুন না। হ্যাঁ, ও ওকে ওকে, sorry for this interruption. So these are the evolutions, those in the generation plans will be taken into in near futures. So with the introduction of these new generation systems, our existing grid is to be evolved in a drastic manners. Okay, so the concept of smart grid will come into this picture. Now the modern grid or existing grid is now to be upgraded to smart grid with the evolution of these kind of renewable energy sources. So the grid is to be upgraded also, since their basic nature are intermittent. At the same time, they are also distributive in nature. So I forget to mention this is they are highly distributive in nature, means so that if we look after the energy density of the conventional resources, so the energy produced per unit area in conventional system is much higher than the energy which is being generated in non-conventional resources. Okay, so that their basic nature, the solar and wind, their basic nature is they are highly distributed. That means the energy those will be developed or will be generated from the solar and wind. They are to be fed into the grid. Now the question is, at which point we will feed it into the grid? Since they are distributed in nature, it is wiser to feed these energies into the distribution side. Okay, depending on their capacity, they can also be connected to the nearby transmission substations. Okay, so depending on the capacity, so for a large capacity of non-conventional resources, we need a large or huge ground space. Okay, so the area will be needed very much large. So that much of energy that can be provided into the transmission systems. Otherwise, for a smaller amount of solar systems or wind systems, we can connect it at the distribution levels. So that's why the grid, which were originally designed to flow the power from the conventional generating units, centralized generating units, to the consumers. Now the consumers are also becoming the producers of the electricity. That's why they are called prosumers. So the energy that those are being generated by the consumers, that can also be fed to the grid. So this is the easiest way of making the use of the solar or wind energy that can be transmitted through these distribution systems, or the energy can flow into the network. So that's why the concept of the smart grid comes into the play, and the power can flow in either directions. So this creates again a problem into the systems. So how the system will be managed, what are the monitoring issues, what are the different fault conditions as the resource are distributed. So there are number of players or in the grids. So the maintaining of them, all of them, and their operations, maintenance, if any fault has occurred, how they can be managed, so etc. Everything will be coming into the picture. Okay, so that's why if we look after the smart grid, so from the environment point of view, we will use renewable energy sources, will conservation and demand response. I am coming to this. Okay, the conservation and demand response, the greenhouse gases, those are the players of environmental issues. From the system reliability point of view, the generation is very variable for the conventional systems, sorry, non-conventional systems. They are highly distributed in nature, their capacity are limited. So at the same time, from the operational point of view, the operational efficiency is to be considered, customer satisfaction is to be taken care, and the supply must be very economics. So we have to consider all these issues, and those are will be considered in the smart grid concepts. So the mass grid basically is an electricity network, okay, that can intelligently integrate the actions of all users connected to it, both generators, consumers, and those that do both, in order to efficiently deliver sustainable economic and secure electricity supplies. These are the key aspects. Okay, so the communication and standards, power system enhancements, environmental economics, computational intelligence, all these are required, okay, in order to implement the smart grid. And also we have to have a test bed where these systems can be tested. So the characters, if we look at the characteristic feature of the smart grid, it is actually active consumer participation. It suggests active consumer participations. Conventional grid does not allow this. Okay, accommodations of all types of generations and storage options. Whatever is the type of generation units that can be accommodated into the systems. So maybe at the distribution level. For this, we need to have new products, services, and also need to have markets, so that the energy can be sold or can be transmitted or radio can be sold by the consumers. So we need a market from where, just like our commodity, we need to have a kind of market from where we can sell the product, okay, or buy our product. Similar is the case for consumers. The consumers will have to sell their energy, or they have to procure their energy from the markets. So the market price is also to be informed to the consumers. I am coming to this point. The provisions of power quality of the digital economy. Okay, so the quality of the power is to be improved with the help of the digitization, and for its various data will be there. Optimization of the assets, and it operates efficiently. Various assets are there. How the efficiency of the systems can be improved. It anticipates responses to the system disturbance. It can anticipate, which is called self-healing. Okay, smart grid suggests the availability of power should be 24/7 hours. Okay, so, and there may have some problems in the grid. We cannot guarantee that the power will be available all the day, but if we can anticipate the failure, causes of the failure, then we can take precautions. So that's why the smart grid suggests we have to provide continuous power supply, and the occurrence of the fault is to be anticipated, and proper measures are to be taken for that. And it is also suggesting resiliency against cyber attack. Since communication are there, so there is every possibility of having cyber attack. So the system must be resilient enough so that cyber attack cannot take place, cannot hamper the system, even the electricity will be available under natural disaster conditions. So these are the concepts of smart grid, and these are the features to be implemented. So with the communications, the necessary software and hardware to enable consumers to trade in energy markets and to provide demand side response. So the demand side response, in order to implement the demand side response, we need the help of information and communication technology. And at the same time, we need to install various sensors, measurements, control and automation technologies at distribution levels. And also in our conventional systems, if we look after the distribution system, so there is no way out of getting any information from the distribution systems. Only thing we can measure the the total energy only at the distribution substations, and how that energy is being delivered to different consumers at different time of the day, there is no way out to measure this. Okay, but smart grid suggests everything is to be measured and proper systems management are to be installed. So the sensing, measurement, control, and automation technologies will also be incorporated into the distribution systems. So that means there will be huge huge devices are to be installed, huge assets are to be there, those are to be maintained. Now, at the same time, we have to install pressure measurement units, and we have to implement wide area monitoring, protection, and control systems. Okay, so these are the essential tools. At the same time, it integrates sensors, measurements, and control automatons. Smart appliances, we need to have smart appliances and smart meters. I will come to these points. And we are also having this power electronic storage technologies. So HVDC, FIATs, power electronics converters, since the energy which will be generated in the solar and even in the kind of biofuels, biomass, etc., or sometimes in the wind, all these are to be fed to the grid. And for that, we need some kind of power electronics converter, maybe inverter, maybe DC to DC converter, whatever is the case. So those kind of converters are required. So the power electronics also play an important role in smart grid development. So the basic components, the primary feeders at the voltage level supply, install industrial consumers, secondary distribution feeders supply residential and consumers, commercial consumers. At the same time, intelligent support schemes will have to be provided for monitoring capabilities for automation using smart meters, communication links between consumers and utility control. Okay, I am coming to this also. These smart meters have to be. So our existing meters, those are not smart enough. Okay, energy meters. Okay, this basic problem of the smart meter is of these existing meters is they can only monitor the total power on aggregated power. Okay, consumption, energy consumption. But in a particular time, in a day, particular day, what was the consumption or what is the consumption? There is nothing to record of these informations. So smart meter provides this kind of information. It stores the consumption status at the instant with respect to a real-time clock. At the same time, those can be communicated to the utility, okay, as well as to the consumer. Those informations can also be communicated to both sides, to the consumer sides, from the metering point to the consumer's home, at the same time from the metering point to the utility control center. Okay, so the energy can also the consumption status can also be monitored from the remote end, both by the consumers as well as utilities, in real time basis with respect to the real time. So that how the energy and each and every household is having a smart meter. So the energy, how the energy at a given time is being utilized by each and every consumers, that can also be monitored with the help of these smart meters. So our existing conventional meters or maybe digital meters are to be replaced with smart meters for successful implement of this smart grid. There should be a communication link between consumers and the utility control. In order to have a DSM to implement, I am coming to this point, energy management component, advanced metering infrastructure, which is very much essential to establish this communication link between consumer and utility, and also to implement this demand side management. Now, what is demand side management? Now, if we look after this pattern, what I have already shown to you, this average consumption pattern. Okay. Now, if by any means, if the user can consume the energy on an average load, okay, instead of this, so there may be 5 to 10% tolerance, not the 30 or 40% tolerance. So that means there will be a typical consumption pattern. If the consumption pattern will be such that by the consumers that the average, it will follow this average line, or which is called base load line, then we will have very large advantage. The first of all, we need not to install generation capacity which is corresponding to the peak demand capacity. We need not to install the transmission line, the distribution lines capacity corresponding to the peak demand capacity. At the same time, we will generate the power corresponding to the base load only, and this will the plant capacity will be designed accordingly so that the plant will run at their maximum efficient point. Plant load factor can be improved and the loss can be minimized, which will ultimately reduce the carbon dioxide gases. So in this way, we can, if this is a kind of thought process, okay. So if we can implement this, so these are the various advantageous points we can achieve. Now, question is whether it is possible to achieve these kind of things. Yes, it is possible, and for that we have to implement this demand side management. In demand side management, what is our role? It is basically, demand side management is basically the modification of consumers' demand of electricity through various methods such as financial incentives and consumers' education. Right at the moment, or right at these days, if we look after me, or if you can also you have of your own habits, we generally utilize our electricity when we require. But if we can change these habits, okay, then the load average consumption can be made according to our base loads. But to change the habits of the user, it is very difficult to change the habits of the user and motivate the users also to change their habits. So for that, we have to provide financial incentives as well as consumers' education. So demand side management suggests the modification of consumers' demand of electricity in such a fashion their total consumption throughout the day can be made in a baseline, like an average line. Okay. Suppose the total energy consumption is maybe hello.
Yes, sir.
Yeah.
Sorry to interrupt. What you are suggesting is that the consumer need to change their lifestyle, the habits of the day-to-day lifestyle of the
Probably one of the measures. Okay, not lifestyle. So it is very difficult to motivate consumers to change their lifestyles. It is not possible.
Yes.
But yeah, it is not possible. But at the same time, if we can provide some kind of financial incentives, say for example, we are having our water pumps, okay, and what is the time of running the water pumps? It varies depending. When we see there is no water in our tank, we just put it on. We do not look after what time we are putting it on. What is the time? Whether it is daytime, whether it is evening time, whether it is midnight time, we do not look after that. But whenever there is no water in the tank, we just put the switch on. But this habit can be changed if we can have a kind of routine, okay, and that routine is to be followed by the financial incentive. Otherwise, it is not possible. Financial incentives, in a sense.
Sir, in that case, the distribution company will suffer losses, or it will be able to make profit. Because if we are giving incentive to the consumers, so the money has to be given. So maybe profit is going to get.
No. This is the objective. Okay, the objective is the distribution companies are also suffering losses. Their capacity is also to be made at the peak demand part the peak demand. Okay. Now, if it is possible, then their capacity of the system's installation will also be very small. That will be reduced. So they have to invest less.
Okay, sir.
Okay.
Yes, sir. Got you.
So there are two ways. Okay. So your total capacity of maybe 1,000 crores. Now, how those 1,000 crores are being utilized? Are being distributed on different aspects.
Yes, sir.
Okay.
Yes,
so the loss is also there. T&D loss is also there.
Losses will compensate for the financial incentive. The
definitely. Definitely. At the same time, you are contributing to the society also by producing less carbon dioxides.
Yes, sir. Got it.
You can at the same time you can provide good quality of supply. The power quality can also be improved.
Yes.
If everybody runs their load at the evening time, that voltage will drops down, depending on the transmission line losses or voltage drop. So that means you will not be able to provide your good quality of supply. So that is the consumer satisfaction. Okay. In developed country, so there is a option of giving penalty if you are not able to provide your good quality of supply. If your voltage gets down, so if we run at the lower voltage, our motors will run at lower voltage, and their lifetime will be reduced. Now, who is responsible for that? The consumers are not responsible. The suppliers are responsible. Okay. So everything will be improved if we can manage this.
Yes, sir.
So this is the
yes, sir.
okay. Yeah. So the consumers are also to be educated. They are to learn when it should be utilized, and the consumers can be motivated in this fashion. Suppose if you run your water pump, maybe at the evening time you have to pay ₹10 per unit. Suppose if you run this motor at the mid time, you will have to pay suppose ₹1 per unit. Okay, if you run it at the different morning time, you can have the ₹2 per unit. So if this is the kind of incentives, then the consumers will always try to opt the minimum prices.
Yes, sir.
So in this way, the habit of the consumers are to be changed. So until and unless you provide some incentives to the consumers, they will not be motivated to change their habits. But it does not tell to not to sacrifice the satisfaction level of the consumers. Suppose you AC is required, definitely there is a summertime AC is required, but you cannot prevent your consumers, you should not run the AC. But since the AC demand is more, you can tell that if you run this AC maybe during morning hour or maybe 10 to 12, okay, this much amount of price will be there. If you run your AC at the evening time, your price will be high. So then there will be a compromisation between the consumer's use and the satisfaction. Whether I will run it for a longer time or we will run it for shorter intervals. So these kind of incentives or penalties, we can say, we have to impose on the consumers. Now the question is how those information will come. That is another issue. But if we can maintain this kind of issues, so that means if we can manage this kind of loads management, the demand will be managed by the consumers. Consumers are raising their demand, and the demand is to be managed by the consumers itself. Accordingly, the generation, transmission, distribution, everything, the efficiency will be increased. So in earlier, what we can, it is our that the generators are to follow the demand. Okay. Now the situation is in a broader sense. I am not giving like this. In a broader sense, if the situation is like this, the demand will have to follow the generation. My generation is fixed. Maybe at 3000 megawatt. Just I have shown this characteristics. Maybe at 3000 megawatt. This is my generation level. I will not increase my generation level. The demand has to be managed in such a fashion that the demand will never rise 3000 megawatt. Okay.
Yes, sir.
So that means that demand has to follow generation in a broader sense. It is not the actual sense. Okay, it is a broader sense. It's a broader sense. So that's why we will not be able to install. It is not required rather to install the peak demand capacity of the generating units, the installation capacity. At the same time, you can run your plants at full load capacity. That means plant load factors can be improved. The efficiency can be improved. So these are the suggestion. Okay, so demand side management is also a kind of suggestion. If we can manage this, if we can install this, implement this, these are our advantageous points. Okay, so we will be benefited in these fashions. Now the question is how we will implement it. I am coming to these points. So usually the goal of the DSM is to encourage the consumers to use less energy during peak hours or to move the time of use of energy to off-peak hours, just like night. Just I have told, okay, that if the pumps can be run or the washing machines can be run at the midnight, okay, those are possible. Not all of them are possible. Okay, so those are possible if we can manage this. I am coming to this. What are the ways by which we will be able to do this? So what are the ways, types of DSM measures? How we will be able to implement this? One is the positive tariff incentives. So you will have to provide the incentives through tariffs. Okay, just rupees 10 per unit, or rupees 1 per unit, or rupees 5 per unit. In Denmark, I just have a kind of read out in some kind of magazine. In Denmark, 2 to 3 years back, in Denmark, if you consume electricity in the evening, in the night time, the consumers will be paid. Okay, this is a negative kind of negative tariff, we can say. So they are being encouraged in this fashion. Okay, so it is very much similar to, like, if you have a kind of market and you are not able to sell all the products or the commodities. So to bring back those commodities to the go down, the transmission cost will be much higher if you can sell them at reduced price. So you are losing. Okay, definitely you are losing. But the cost of taking back to the go downs is higher, will be higher if you sell them at a lower price. So this is the kind of issues. So in Denmark, they are providing negative tariffs. That means if their consumers are being encouraged to consume energy at the night time, and if they consume, they will be paid. Okay, so this is the way. So how they are managing this? Because if they reduce their plant load at the night time, so that much of loss can be managed by providing this kind of negative tariffs. So these are the ways. So, but in India it is not possible. Maybe, I do not know it is possible, whether it is possible or not. So if this kind of negative tariff concepts come in India, probably everybody will go to the night time to consume energy. So in the peak will be shifted to this night time. Okay, I do not know, but this is the scenarios. But so the positive tariff incentives allow customers to schedule demand activities, and negative incentives should also be there, are charged for the continued operation of inefficient equipment with unnecessary high loads. So we will also have to improve our equipment with the efficient equipment ones. Suppose we are having a very old fans or old motors, those are inefficient, those are to be removed. And if you run those devices, you have to provide penalties, since they are consuming very high loads, as well as they may generate pollutions to the systems in terms of electric pollutions, maybe producing harmonics or etc. So this is intended to encourage customers to upgrade equipment and thereby reduce electrical demands. I am coming to these points also. So the main types of measures: energy reduction program, load management program, and load growth and conservation programs. The load growth should be there, and how that can be conserved. So these are the 3 types of measures. Those are to be taken care for DSN implementations. Energy reduction programs, where the reduction of demand through more efficient processes, buildings or equipments are encouraged. I will go through this. Load demand management programs, changing the load pattern or encouraging less demand at peak times and peak rates, load growths. I'm coming to these points. Energy reduction programs, lighting. We are all know today, generate 10% or more the industrial, is that point? Yeah, industrial plants, and 50% or more are the commercial buildings consumes electricity. The use of efficient fluorescent lamps, tubes, maybe LEDs and other low energy light sources, CFLs, etc. So instead of by replacing those incandescent lamp by using efficient fluorescent lamps or LEDs. Today we are all using LEDs. We know that much of consumption of LEDs. Okay, so today maybe 9 watt or 10 watt LEDs is sufficient, giving a sufficient light, which was originally given at 100 watt bulbs, incandescent bulbs, so that the consumption can be reduced, overall consumptions. They consider energy efficient electronic ballasts. The ballasts are required to ignite various high power high mast lamps or etc. in the roadsides also. So those can be made electronic ballasts, and those are energy efficient. Clean the luminarities regularly, so that the maximum amount of light can be, the produced light can be fed to the consumers. Use appropriate lighting levels at different parts of the work area. Maybe suppose I am in a classroom and the lights may be mounted at the ceiling. If the height of the ceiling is 20 feet, so that can be reduced. So the light level can be lowered, so that the minimum number of light can be required. If we feed the light at the 20 feet height, maybe 20 number of lights will be required. But if we feed it at the 10 feet height level, so the number of lights will be reduced. Okay, so that's the appropriate light level. Maybe in the drawing room or in the reading table, we can put our table lamps on instead of making the total room on. Okay, so these are the cases. So appropriate light levels, install lights at working levels where possible, not necessarily at the high ceilings. Use natural lights where possible. Use transparent or roof panels or skylights. In earlier days, when electricity is not there, the earlier heritage buildings are made like this kind of translucent roofs or skylights. They are utilized. Today, we have to design our homes or flats in such a fashion that the maximum natural lights can be entered in our house premises. Paint the walls and ceilings with white or bright colors, not the dark colors, so that with minimum wattage of lights can improve the light reflection. Okay, so that we will be, and if my wall is painted with dark colors, so we need high wattage of lights to install. The motor as a drive system, so we use cog belts or improved gears. Smooth belts are often slips and it is inefficient. Install improved bearings and lubricate regularly. Check power factor regularly and improve the capacitor banks. I am going quickly through the slides since I am lacking the time schedule. I think these will be very much easy to understand. Install close to the running running equipments, the motors and drives. Motors cannot be fed at a very longer distance, longer array distance. Near the load point, the motors should be fed so that the charge loss can be minimized. Maintain all the equipment regularly. Similarly, for the other systems, motor and drive systems may consume 50% of total electricity, and poor motor performance is typically a major source of energy losses. So that's why use properly sized motor and only run when needed. Use high efficient motors. Use electronic variable speed controllers, rather our conventional variable speed controllers where motor loads are variable in nature. So these are actions can be utilized for energy reduction programs. Here we will not suffer our satisfaction level, but utilizing those energy efficient or energy reduced components, we are getting the same what we can say service, same satisfaction level, but the energy consumption can be reduced by using this kind of techniques. Okay, for the households, we can with these no cost or low cost measures, we can incorporate all this. Maybe sealing or insulation for air infiltration or hot air escapes. Okay, so in our particularly tropical area, since it is basically hot, we need cooling. So if the AC is run and there will be ventilation between these windows or etc., so air infiltration will be there. At the same time, in the cold areas, the hot air should not be leaked to the room, escapes to the room. So the sealing and insulation is required. For this, floor, wall, ceilings, insulation are to be maintained. Door and walls, fans, vents, heating, cooling, ventilations, etc. Electric outlets and plumbing penetrations through walls. So all these precautions are to be needed. Okay. Then the washing machines, dryers, dishwashers only run cooling temperatures. Use curtains to insulate at night. Okay, and a sun blind to cool if hot, or open to let sun in if the cold. So these are the sun blinds can be utilized. So these are the techniques. and replace incandescent light with the LED or CFL lights, use of energy efficient equipments and appliances. So all these can be utilized for energy reduction programs. So for a typical example I am giving here, if the lamp, okay, so the domestic lamp, if it is of 60 watt, okay, and the CFL lamp is 14 watt, the same, the how much wattage I can save, this is 46 watt energy can, so this is 77%. Similarly for the ballast, similarly for the industry, HPMV, metal vapor, okay, so this is 250 watt. If it is sodium vapor, it is 150 watt, so 100 watt is being saved. Similarly is the case for commercial magnetic ballast like this, magnetic ballast with electronic ballast, so this much of energy can be saved. Similarly for street lighting, if we can utilize sodium vapor 250 watt LED, if we replace this LED, so we can save 100 watts. We are getting same satisfaction level, but the energy consumption is getting reduced. So these were the is the percentage of energy that can be saved using these kind of areas of utilization of energy. So this is the energy reduction program. Now, in terms of load management program, there are three measures: energy reduction program, load management program, and load growth and conservation. Okay, so the second one is the load management programs. The type of load management techniques are load leveling, load control, and tariff incentives and penalties. Here is the kind of load leveling procedures can be maintained. Peak clipping, that means the demand may be made in such a fashion the peak of the load can be reduced. Here, if we look after the total coverage area, so the amount of energy consumption will be reduced. This is peak clipping. Here is the load shifting. The total area, if we consider the total area of the consumption, that can be shifted. The peak can be shifted to other non-peak areas. Okay, when there be minimum energy, just like I have told, if the washing machines or motor can be run at the off-peak loads area times. So this is a load shifting. This is basically techniques which is basically load shifting. But we are utilizing the same loads, okay, not at the peak time. Similarly, the valley filling. Here, this is the reverse. Instead of making this kind of lower level of energy, the level of energy can be increased by some kind of filling. The consumption can be made increased here towards the average level or peak level. Okay, this is a kind of valley filling. If you go to the our what we can say Purulia pump storage, in that case, in the evening time, the thermal power energy is being utilized. The thermal power energy is being utilized. Just a minute. Sorry, I am sorry that right now here is the load shedding. Okay, my laptop battery is very low now. I do not know how long I can continue. I'm very sorry.
It's okay, sir. It's okay, sir.
It is a load shedding time.
Yes, sir.
So it suddenly shows the battery is running low.
We understand, sir. No issue, sir. We understand that. It is beyond our control, so we understand, sir. No problem. So you can, if you want, you can sum up in a nutshell, as long as the battery permits.
I just go through this. Yeah, load management programs are here. Okay. Definitely using these loads, the total concept is we can have some kind of essential loads and removable loads. The smart meter has the facility of segregating these two. So smart meter can be utilized for essential loads. Okay, under extreme conditions, the load can be managed by the smart meters. The essential loads, load controls are there. The tariff incentives should be there. I am quickly going through this. It will be very short time, I believe. Load growth and energy consumption can be managed using these conventional or non-conventional energies. Okay, so now in order to implement the DSM infrastructures are to be required. The advanced metering infrastructure, the smart meters, the consumers are to be so that the consumers can take the communication advantage with the grids, and they can be in terms of the grids, and they will get the benefit of the systems. This is the advantages of the DSM. These are the advantages of the DSM: the reduction of customer energy bills, reduction in need of new power plants, transmission systems, simulation of electronic development, creation of long-term jobs. It can create long-term jobs to the new innovations and technologies, increase competitiveness. So these long-term jobs facilities can itself create, can solve our what we can say unemployment problems. Reduction in air pollution, reduction dependency of foreign energy resources, reductions in peak power prices. Okay, these are the typical examples where we can utilize standard fans as well as BLDC fans. Today, BLDC fans are utilized. The power wattage of consumption BLDC fans is 5 to 30 watt, whereas standard ceiling fans is around 75 watt. So if we look after over a 10 years cost, the total cost is around 10,800 rupees, whereas it will be just half of that. And whereas the cost of BLDC fan is around 2,600, conventional it is around 1,500 or something else. So with the little bit of increased price, we can get so much of advantage. Similar is the case for AC, very 5-star rated AC, inverted AC like this. This much of energy power can. Oh, so fortunately, power has come. Okay, so I am fortunate enough.
Okay, sir. It's okay, sir.
Yeah. Okay.
So you can take your time now.
Okay. Yeah. So if I can go back to this is the DSM infrastructure, load growth. I have quickly covered. So okay, let me tell something. If we take these various ACs, okay, just I have already told. So this is 2-star rated ACs, 5-star rated ACs. So the power consumption point of view, we can the actual power consumption is 2,505 kilowatt, whereas for 5-star rated it is 2,079. Okay, so the power consumption is reduced in all the way, but we will get the same satisfaction level. Okay, but as we go on with the upgraded or energy efficient devices, those devices can be termed as energy efficient devices. Here, this is a 5-star rated inverter. So the cost of the energy efficient devices is a bit higher. But if we look after the overall energy consumption scenario, okay, kilowatt hour, so it will be very much advantageous to the consumers. As well as what we can say, this is a kind of payback period. The difference in cost can be paid back with the reduction in the energy consumption. Okay, so you can term this like this. Similar is the case for refrigerator. If there is a kind of refrigerators. Okay, so this is a frost-free refrigerator, 5-star and no star rated, and the consumption of this pattern will be annual energy consumption like this is 274 and frost-free is 364. This is 5-star rated. Both are 5-star rated. Whereas in no star rated, this is 1,000 kilowatt hour. Whereas 5-star rated, it is 364 only. But the price difference is only 10,000. So there will be a payback period. So the difference can be paid back in terms of the consumption of the energy. Okay. At the same time, we are utilizing this kind of energy efficient devices. The consumer will be benefited in terms of price. At the same time, the consumer is helping to the discoms or the transcoms or the utilities to manage their electricity based on their reduction in demand. Similarly, for irrigation pumps, they are the typical examples. Okay, here the energy consumption. This is a submersible pump, existing old pumps. The annual electricity usage. This is 22,800 kilowatt hour. Okay, but with this energy efficient pump, it is 8,400. The same power rating. Okay, the rating power rating is same. Okay, and the efficiency is 0.5. Here it is efficiency is 0.2. Energy efficient pumps, maybe BLDC pumps, maybe permanent magnet motor pumps. So those are the pumps, motors. The pump are basically driven with the motors. So the motors are the energy efficient motors. So if we can utilize this energy efficient motors, the energy consumption is, there is a huge difference in the energy consumption. So again, the price can be paid back in this fashion. Now, before coming to this point, I just highlight again, come back to this point. So load growth. So here I was here in the load management program. So it was basically valley filling. What we are talking about, the suppose Purulia pump storage, the power plants at the evening time, they are also producing the peak powers, but the night time, they have to reduce their power as the demand reduces. But if those energy, instead of reducing the total generation, if those energy can be utilized for filling the valley, just like our pump storage. So those energy utilized to raise the water level for the storage purposes. Okay, so the energy is being utilized, and when the demand will come, peak demand will come, those water can be utilized to generate electricity, so that the plant or thermal power plants can run at an average load. So this is the basic objective of valley filling. Similar is the case for energy consumption. Okay, so the total energy can be reduced with the same satisfaction level. The conservation can be reduced. Okay, so the energy conservation will be there. The load growth can be managed by using this kind of. So this may be the load growth, but this can be managed with the help of these energy efficient devices. So that is the conservation. And if we look after this kind of load growth modifications, end user applications, we can suggest for the peak clipping, HVAC, okay, and electric motors. So they are strongly recommended for the demand side management to implement. Whereas lighting, refrigerations, low load applications, they are occasionally utilized for the demand to reduce, peak clipping to reduce. Valley filling, these are, I have already told, it is not for any kind of applications. Those are being utilized, valley filling, generally utilized by the utilities itself. Load shifting, so the HVAC that can be shifted, light load, refrigeration, electric motors, all these can be shifted to different times, just like this one. Okay, if we can follow my mouse, so that the total energy consumption can be made constant. Energy conservation, like this HVAC, electric motors. So those are made, I have already shown, with the energy efficient devices, so that the total energy consumption can be made. Strategic load growth, like HVAC, that can also be managed. Flexible load shifts, that can also be managed. So different types of suggestions are there to manage all these kind of loads for load management programs. There is another part also, load control. This is a load control. Okay, so the heating, cooling, ventilation, lighting, etc. can be switched on and off, often remotely by the utility as kind of essential loads or removable loads. Just I have already told, suppose I don't want to increase my generation level, I can fix my generation level at 3000 megawatt. Just I have shown, this is the baseline if we follow this particular characteristic. Now, if suddenly the load demands comes higher, so what should be the case? Then the utility will have the provision. There should be kind of agreement also. There should have some kind of laws. Okay, electricity regulations should also be there. So utility can remove, in the extreme case of peak is becoming higher and higher than the base loads. The removable loads can be disconnected from the supply. Okay, and this can be done with the help of the smart meter. So smart meter will be designed in such a fashion. The smart meter has two outlets. One outlet can be connected to the essential loads. Another outlet can be connected to the removable loads. In case of contingency periods, not only this load management program only, in case of contingency periods also, instead of making a complete blackout of the area, the essential loads can be provided. Maybe a single fan, maybe a CFL lamp, or for computer or refrigerator. This kind of essential load only to be provided. So this, and the rest of the loads can be disconnected from the supply, and those control are to be made with the help of the smart meters. So with the help of these communication systems also. So okay, so there are two parts for the smart meters. One is essential loads and the removable loads. So the load control for participating in the DSM, okay, can also be possible with the help of these removable loads. There are the consumers may have backup generators. The load control can also be made. The consumers may have backup generators or energy storage capability, and generally have an interruptible agreement with the utility in return for a special rate. Okay. Suppose we are having a kind of wedding ceremony. There is a hall. Okay, there may be a kind of agreement between the utility and the consumer that the energy should not be disrupted at any time. Okay, so the energy should be there for all the duration. There, you have to take that kind of precautions. So the utility will put a kind of backup generators or energy storage devices at that point. But for that, the consumers has to pay with the special rate. So this kind of agreement can be there. Okay, so this load can be controlled locally with the help of this kind of special generators or energy storage devices. And for that, we have to make some kind of special agreement. Utilities may even call on on-site generators to meet the peak demand on the grid, so that it will not affect the grid or generators. The utility may also use rolling blackouts to reduce demand. Just I have already told. Instead of making a complete blackout in a particular area, the blackout can be rolled to different areas with the provisions of providing essential loads. Okay. So that's why the utility may use rolling blackouts to reduce demand when the demand surpasses the capacity by systematic switching off of the supply to the areas with a supply region. Okay. So tariff incentives, the utilities encourage a certain pattern of use by tariff incentives to achieve a better price rate for their energy usage. This includes time of use rates, where utilities have different charges for power usage during different periods, time usage. Power factor charges, where users are penalized or having power factors below a fixed threshold, usually 0.9 or 0.95. Real-time pricing. So for all these, okay, the utility as well as consumer, they have a kind of communication links, and those are being done with the help of smart meters. The utility has a kind of control room, maybe at the remote places. They will take the help of advanced metering infrastructure. They will communicate with the smart meter through this advanced metering infrastructure, and there will be another device in the consumer's premises which is called in-home display, or even today we can think of mobile display. Okay, the display can be put into our what we can say apps. Okay, mobile apps should be there, so that the consumers can visualize what is the current time and what is the price for using a particular loads, what is the tariff rate, okay, and how much energy is being consumed in a particular in my house at that time. The consumers will be able to see, and what are the controllable loads, and whether there is any wastage is going on or not. Suppose there is nobody in a particular room, but the room is still enlightened or fan is running on. So all these can also be put off from the remote locations. So these are the points coming. Okay, so by this way, so the consumers can participate in the demand side management. Okay. And the load growth, I have already explained. The load growth programs are implemented with the intention of improving customers' productivity and environmental compliances while increasing the sale of kilowatt of the utilities. Okay, the consumers can produce their energy so that the overall growth can be managed. The increase in the market share of the utility enables an ability to fill valleys and increase peaks. The utility may use rolling yes, the programs can often divert unsustainable energy practices to better and more efficient practices, okay, such as the reduction of use of fossil fuels and raw materials. So these are the definitely, if we can manage with this, the load growth can be managed, as well as we can use reduction in fossil fuel or raw materials. So this is the demand infrastructure. I have already have a snapshot of this. Yes, just have a detailed. The smart meters, I have already spoken. The smart meters, in-home display, smartphone, I have just told. And the smart meters will be connected to the consumers premises, and the consumers will participate to the rest of the grid through this AMI as well as smart meter. Okay, advanced metering infrastructure. So that and there should also be a kind of energy market. This is the market. The consumers will be communicated to the market so that the consumers will be able to know the current scenario of the energies or the prices of the energies. And if the consumers is having his own generation, maybe in the form of solar, maybe in the form of battery storage, maybe in the form of even in the electrical vehicles, the consumers may have his electrical vehicles, and the energy which is having in the electrical vehicles, if that can be sold, the rest of the energy, suppose the total energy may be 100 kilowatt hour, and for the day when the consumer will go out, maybe his consumption is around 50 kilowatt hour. So the rest 50 or 40 kilowatt hour can be sold to the grid from the electrical vehicles. So this is also possible. Okay, so those are to be taken care, and when the consumer will be encouraged to do this, if the consumer sees the price is much higher, if the unit if the unit may be 10 rupees per hour per kilowatt hour or something else, whereas the consumer is purchasing the electricity as 5 kilowatt hour, so the consumer will definitely try to sell the energy. Okay, so these are the incentives. So all this information should also come to the consumers, and for this we need to have this kind of DSM infrastructure. I have already speak out these things. I'm not going into details. So DSM challenges. The challenges, what are the challenges? So it is a monopoly in the power market structure. Still now we are having no competition, which leads to the traditional and inefficient tariff structure. So, but it is very difficult. If we have a kind of, just like our mobile phones, there are so many competitors, Vodafone, BSNL, Airtel, so many competitors, Jios, but it is not possible for so many of competitors, so many of vendors that can provide electricity, since we have to follow a particular common transmission line or distribution lines. So lack of creating awareness among consumers about the efficient use of energy. These are the challenges. Lack of creating awareness among the consumers. Lack of energy efficient environment. Okay. Lack of creating awareness among consumers about the energy efficient usage of energy. Maybe I am having a kind of incandescent lamp of 100 watt. So it is very difficult to convince me why should I replace this incandescent lamp with a kind of CFL lamp or LED lamp, which the cost is very high. So it is a kind of what we can say lack of awareness among the consumers. Okay, so if at the end of the day or at the end of the some few months, the energy price will be compensated. So these are the awareness that should be built up. Okay, similar is the case for energy efficient environment. There is a huge gap between supply and demand of energy still now. Lack of proper incentive schemes to consumers on using energy efficient appliances and electricity to implement DSMF solutions. There is a very much lack of proper incentives. For this, we need to implement the regulations. Okay, so there is a very much lack of regulations from the government also. So what will be, and if anybody does not provide the price, so what will be the case, and what should be the percentage of incentives, what is the time of use, tariffs. So there is so many of lacunas are there in the existing what we can say electricity norms. Lack of accurate long and mid-term forecasting of load demands by GENCOs. It is also essential. Okay, so how the demand is growing up, or how in a particular area, those surveys are being made by GENCOs. So the accurate and long-term and mid-term forecasting is very difficult. A lack of understanding load or market research to identify end-use patterns and market barriers. So these are the very much challenges. So our basic objective, we are having our budding engineers, we can start at least in our home implementing DSM schemes by replacing our age-old inefficient devices, electrical devices, with the new energy efficient devices, for which it is very difficult to it is very difficult to make aware of the consumers and to convince them what will be the benefit of utilizing energy efficient devices. First of all, what is the terminology energy efficient uses or energy efficient uses of the devices? It is very difficult to understand to them, particularly in the rural areas. Okay, in the rural areas. So there will be a mind blockage. So if a particular consumer or is having a particular, suppose TVs or old age TVs. Today we are also having TVs or CFL or LCDs or LED TVs. The energy consumption pattern of these two LEDs is highly different. But if you go to a particular consumer, okay, you replace your what you can say old age, that is cathode ray tube, okay, CRT TVs to a LED TVs or a CFL. So he will have to face so much of questions. Why should I go replace it? It is running well. So this is the mind blockage of the consumers. So we have to aware them. So this kind of awareness program are to be made frequently so that the consumers can be literated in these specific terminologies. If we look after the electric savings through the DSM in residential sectors, this is the Indian scenarios, overall scenarios. In 2021, the total electricity savings is around 1800 to 5400. Okay, and if we can think of this kind of gigawatt hour energy, which is very much similar, equivalently 1.2 to 3.6 million residential air conditioners. And with this reduction, with the DSM, if we can implement DSM in 2021, and with this DSM implementation, we will be able to reduce 1100 to 3400 kilotons of carbon dioxide emission, and the cost saving will be around 9 to 27 billions of rupees. And in 2020, this is a projected plan. If we can implement this DSM, the electricity savings will be 3,400 to, this is only this year, okay, 10,200. The carbon dioxide emissions will be reduced around 1,800 to 5,300, and the cost savings will be 17 to 51 billions of rupees. And if we look after, if we take this total 2021 to 2030, this is a cumulative over 10 years period, the total electricity savings will be 25,400 to 76,000. This much of wide variations is considered depending whether the DSM implementations will be successful or not. This much of energy savings will be possible, and the carbon dioxide emissions 14,000 to 41,900 kilotons of carbon dioxide reductions will be possible, and only using these DSM technologies, DSM schemes, and the cost savings will be 127 to 380 billions of rupees, which is equivalently 170 megawatt to 510 megawatt of rooftop solar PV cost. And this is the emission stations. This is with the fuels, coal, fuel oil, and gas. This is conventional, and the carbon dioxide emission will be like this. Sulfur, SOx, there are sulfur dioxide, sulfur oxide, something else. So nitrogen content, fly ash like this, and the emission reductions will be, okay, this is up to 10. So these are the initial stage of DSM implementations. So it is now recorded like this till now. Carbon dioxide is 87,688 kilotons. This much of terawatt hour energy is possible. This is not in India. This is a global scenario. Okay, this is the global scenario. This is not in India. This is global scenario. So this is a type of DSM projects planned. Okay, so by which we will be able to implement this DSM, and if we can able to successfully implement this, so we will be very much happy, as well as we will be very much environment friendly. So and we can have so much of benefits or advantage to various sectors of the electricity as well as consumers. So with this, I conclude. Okay. So thank you, everybody.
Thank you, sir.
Okay. So if any question comes. Yeah.
Yes, sir. We would, first of all, all of us from Department of Electrical Engineering and on the behalf of management of BBIT, we would again like to thank you that you have taken a time out of your busy schedule to address us and the listeners regarding the details of demand side management. We get to learn and know so many new things regarding the demand side management, especially the saving in CO2 emission and sulfur dioxide emission, these things, including the saving in cost. But what we also learned is that this demand side management, it has the great potential of giving a saving in your pollution and saving in cost, but it requires a change in the behavior of the consumer, and that
Yeah.
that and the change in the behavior of the consumer can be made possible by making some changes in the law and electricity rules.
Yeah.
So these things are there.
Mhm.
So
The incentives should also be there.
incentives to do there. So, sir, thank you, sir, once again for your nice and very informative lecture. And I would now hand over the session to Afaq Wajid. So, Afaq, are you there?
Yes, sir. Thank you, sir.
Yes, please.
Uh, our Dean Academics, Professor Dr. Narendra Jana, sir, is with us, and I'd request sir to please put forward his views.
Good
Thank you, sir.
afternoon, Bera sir.
Yeah.
Myself,
Okay.
Professor
Good
Naresh
afternoon.
Jana from Head of the Department of Electrical.
Yeah. Yeah. Yeah.
Yes, I am here since last 2 years with BBIT as
Okay.
Head of the Department of Electrical Engineering.
Okay.
I am from IIT Kharagpur,
Okay.
master's degree and then PhD from Jadavpur University. And
Okay.
I
Okay.
was in industry for 13 years. I was in mostly that control and instrumentation of, let us say, thermal power plant, refineries, and
Oh.
others.
Okay. Okay. So you are very much aware of all these
Yes.
issues.
So
Yeah.
from my point of view is definitely it was a nice lecture. And as far uh, as you know, most of our students who
Mm.
even are from the MTech master's degree, and we
Mhm.
have the masters in power systems. So definitely
Mm.
this particular session will
Mm.
give the insight to them to take up some kind of, let us say, project.
Okay.
Let us put it this way. Uh,
Yeah.
Demand side management, definitely it requires the small smart devices,
Okay.
even
Okay.
maybe that kind of devices now, as you know, because of this pandemic situation, we have to push to manufacture in local market itself. So
Mhm.
there will be a huge job profile which will be required to
Mhm.
really supply this kind of huge number. As usual, the Indian market is so huge.
Yeah.
Even to really to provide this kind of devices to all households, it
Mhm.
requires large manufacturing base. And
Yeah.
the
Definitely.
engineers who are really, let us say, going out as a, let us say, graduate engineers and graduate postgraduate engineers, so
Mhm.
they would definitely have a lot of opportunity to work with
Yeah.
in manufacturing base, even in their work.
Definitely.
As you know, that
And
earlier,
at the same time, this will create a huge job opportunities also.
that's what I'm saying.
Yeah. Yeah. Yeah.
Earlier, it was only WB, ACB. Now it has
Mm.
broken down to your PDCL and then
Mhm.
TCL and then DCL. So
Mhm.
similarly, as a consumer, as a
Mhm.
common man, maybe
Mhm.
I will have three or four such service providers to
Mhm.
have my own electricity at my residence.
Yeah.
So definitely that days are not far away. So
Definitely.
if I do have, let us say, choices, so to
Mhm.
implement all these kind of things, definitely
Mhm.
in the years to come, we
Mhm.
have to have lot of things need to be changes in terms of awareness among the consumers, even not only the consumers, even the service providers who are providing the service, utilities and all those things. So that there is a huge potential in this particular area. So definitely this particular session is very much beneficial to the students of our college. Even, let us say, if someone has joined from the outside, and very much thank you very much for your presentation. and definitely we are also enlightened, and especially even the junior faculty, they can also take up some things from out of your lectures.
Okay,
Thank
okay.
you very much.
So if it is a useful one, then it is my success. Okay,
Thank
definitely.
you, definitely,
Yes, sir.
definitely.
It is success, sir. It is
Yeah,
certainly a success.
yes, yes. So if anybody is getting interested, if they do something, so it is my success. Okay then. So we
It
need
was definitely a
we
grand
need
success, sir.
yeah we need to actually make some programs frequently to the outside of our consumers regarding the utility of demand side schemes, energy efficient devices. So we need to educate our consumers. Okay, so that is a big challenge for us also.
Even this kind
Not
of, let us say, this
yeah
kind of seminars or
yeah
webinars,
yeah
I was maybe in next time we may have some guys from WPTCL or ACTCL, so that they
okay
can have more, let us say, more lights
okay
into this, isn't it? So
okay
next
then.
time definitely we will be in touch with you, so that next time program will be much better than okay present now. Thank you,
Uh,
Okay.
thank you, sir.
TIC Electrical, Mr. Shubhajit Roy is here. Sir, I'd request you to please say a few words. Shubhajit, sir. Okay, I guess he is busy with some other work.
Probably.
Sir,
Okay.
students who had been watching online,
Mm.
uh, both from diploma, BTech, and MTech as well, they have extended their thanks on the YouTube chat box to you for
Okay.
such an illuminating
Thank,
session.
thank you all of them.
I'm
Thank you
conveying
all
their
of them.
message to
Okay.
you.
Yeah. Okay. Thank you all of them
Afak, Afak,
for your patient hearing. Yeah.
yes, Afak, can you continue with the question answer session if
Yes.
somebody
Is
has
there
query?
anyone having any questions for sir?
Yes. If is there any
Sir,
question? Yeah.
sir, at least I just was wondering that
Yeah.
in one of the slide you were mentioning that if somebody is using inefficient devices like old fan or that, so
Yeah.
they
Yeah.
will be given some
Right.
sort of
Uh,
penalty.
penalties.
So,
Yeah.
so how the meter is going to detect whether the fan used is a BLDC or it is a single phase induction motor, or it's old or
Uh,
that?
Actually, this is a very good question. So this is a technological challenge. Okay, to identify the loads. So the research is going on in these directions. Clear? So
Okay,
this
sir.
is not for today's focus. This is a focus area for a large or few new the power system scenarios. So we have a kind of vision like this. So if
Okay, I
one
was
day
actually.
comes, we will be able to monitor the type of loads or identify the type of loads. The research is going on. The identification of the load is also going on, and all this will be done through the smart meters. Okay,
Sir,
all these will be okay.
harmonic content will be used for detecting the type of load
Not
we are.
only the harmonic content, maybe harmonic content one of the parameters, the power consumption return pattern, okay,
Hmm.
and how much power it is generating, what is the efficiency of the system, and definitely power is harmonics is one of the issues, power factors, as well as distortion, how much distortion is creating. So all these issues are there to identify a particular device.
Okay, so we can't have some sort of inspection from the local distribution company into some household
Right
for,
now we are not having these kind of scenarios right now,
because
but
that will require some sort of changes in the law or like that maybe the
definitely,
rules.
this is one issue. At the another side is we have to install advanced metering infrastructure. It is yet to be there. Okay, in some part of our country, as a part, suppose at Gurgaon or something else. Okay, mm, the a prototype project, pilot project is being installed to monitor the consumer's pattern using some kind of advanced metering infrastructure, communication systems. So the installation of this AMI as well as smart meters, as well as their analysis is very much important in order to implement all these particularly equipment which to be identified.
Sir,
This kind of applications.
the theft of power, can
Yeah,
it be limited by
this
use
is
of smart meter? Can we limit the power theft by use of smart meter? Is it possible?
uh, 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 the smart meter is itself being bypassed. Okay,
Okay.
So there should also be other schemes, other technologies, by which the theft of the power can be minimized. But the thefts are very clever. Okay, so
Okay.
whatever technology is being discovered, the thefts are well ahead of that.
Sir, what I was wondering, can we have some sort of prepaid meter? I mean to say the consumer will charge the.
It is already have. It is already
Yeah.
with us. Prepaid meters are already with us. Okay, but
Yeah.
if somebody bypasses the meter totally,
Okay.
then what will happen?
Then random inspection may be one of the possible. I don't know,
Yeah.
sir.
So you have to have a kind of regular monitoring. So if smart meter is there and you can have a kind of regular monitoring, that is possible with the smart meter. In that case, smart meter data analysis is helpful. So there are techniques. Those are also being. This is also a kind of research topic, that the detection of the theft is also a kind of research topics based on your smart meter data. If it is possible, there are data analysis techniques. Okay, various artificial intelligence techniques should be there. So by utilizing all of them, you have to detect the electricity thefts.
Okay, sir.
Actually, these are the parts of our commercial and technical losses. Okay,
Yes, sir. Thank you, sir.
commercial losses.
Thank you,
Okay.
sir. Thank you.
Any more questions from anyone?
Is there any other question? Or if you have any questions, you can mail me. Okay, no problem. In the next time also. Afak, you can give my mail ID to all of them, or the participants, so that if
Sure.
they have any questions, they can mail me.
Okay,
I
sir.
will. I will.
I'll share it with them.
Yeah.
Okay, so with this we come to an end of today's session. Thank you, sir, for such an illuminating lecture. And
Okay.
I would request all the dignitaries and faculties and other participants to stay tuned for tomorrow's session at 11 o'clock. Thank you all for joining us for today.
Thank you,
Okay.
sir. Thank you very
Okay.
much.
Thank
Thank
you,
you.
sir,
Thank
once
you all.
again.
Okay. Okay. Thank you very much. Okay.
You're welcome, sir.
So, can I leave now? I have a meeting from
Yes, sir.
4 o'clock.
Yes,
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 sir.
sir.
Another
Yes,
meeting.
sir, please.
Okay.
Yes,
Okay
sir.
then.
Thank you
If you
so much.
permit me,
Yes,
I can
Yes,
leave.
yes, yes, sir.
definitely. We are going to end our
Definitely, sir.
session. We are going to
Okay
end.
then. Okay. Thank you.
Thank you.
Sorry, sir.